Today's lesson over section 5.5, the substitution rule. Now here, when we're taking integrals, and we kind of alluded to it in part of 5.4, where sometimes we're going to have the chain rule involved into the integral, and we have to be able to adjust based on what the chain rule would be for that function. So we're going to use the substitution rule, which is where we take our function of the inside portion and set it equal to u, and that allows us to take something out and figure out what it would have been so that we can actually find what we're doing or find the actual integral. So here, we always look at the inside portion. So that's why I'm saying that u is equal to 3x squared plus 2 because it's inside that whole of cubed. And so first I take u and take the derivative of that to see what it would have been. So it's 6x. So in that case, notice that 24x is there already out front. And so I can separate a 4 out and make kind of like solidify a 6x out of there. And so 6x and x would be, or dx would be representing du. And then the u portion is inside that cube part. And so I can substitute those in. That gives me a lot simpler function of 4u cubed. And because 4 is a constant, I can move it out front. And then I can take the antiderivative of just u cubed, which is u to the 4th divided by 4. And then with that 4, it reduces to give me just u to the 4th. And then I'll need to plug back in what u is representing. So that's 3x squared plus 2 to get my final answer of 3x squared plus 2 all to the 4th plus c. For letter B, we have e to the negative 4x dx. So we'll set u equal to the negative 4x because that's the inside portion. Here, as you notice, there is no negative 4 when we take that derivative in our integral. So we'll need to rewrite the du portion so that we can include the negative 1/4, so the opposite, into our integral. And so we'll do that. We can move that out front because it's a constant. That allows us to find the integral of e to the u, which is just e to the u, then plug in what u is to get our final answer. On letter C, here we'll set u equal to 2x plus 4, taking the derivative. Once again, there is no 2 out in front as a constant, so we'll need to rewrite that and have it as 1/2 du. And so we'll plug in what u is and what dx is for that. And then that allows us to move the 1/2 out front. I can rewrite 1 divided by the square root of u as u to the negative 1/2, and then take the antiderivative of that, which allows me to get it to u to the 1/2, and then replace the 1/2 and 2 to get just u to the 1/2, and then plugging in u in for what it originally was, which is 2x plus 4. So then I get my final answer there for letter C. Now letter D, I do need to do some finagling because here, when I take the derivative of cosine, if I set that equal to u, and that just gets me sine, that doesn't allow, like there is no sine, and that allows me to have like an x in my integral with a u, and that's just not gonna be something that's possible for us. So we rewrite it as x cosine squared x times cosine of x. And then we can insert our Pythagorean identity of 1 minus sine squared, and then distribute, and then we can separate it into 2 integrals because I know what the integral of cosine x dx is, which will just be sine of x. So I can kind of simplify that without too much problem. Here, if I say sine of x is my u and take the derivative of that, that is cosine, and there is a cosine dx right there, so then that will work out very nicely. So I'll plug that in as my u, so I'll say u squared, and then my du, and then take the antiderivative of that, which is u cubed divided by 3, and add my plus c, and then I'll plug in what u is, which is sine of x, and that'll give me my final answer of sine of x minus sine cubed of x divided by 3 plus c. Letter E, we'll set the denominator of 1 minus 2x as u, take the derivative. There is no negative 2 there, and so I'll have to rewrite that and say negative 1/2. But as you notice, there's still an x a part of our integral, and I can't really have that. So Another way of getting around this is going back to our original statement of u equals 1 minus 2x and solving for x so that we put it in terms of u, and we can insert that in for x so then we can get all values of u and we don't have to worry about dealing with an antiderivative of x and u. That negative 1/2 I can move out front, and I can simplify my complex fraction there by multiplying by the reciprocal of u over 1. That negative 2 in the denominator can move out as well, so because it's like also a negative 1/2. So negative 1/2 times negative 1/2 gets me 1/4. So I'm left with u minus 1 over u. I can separate those into two fractions and then take the antiderivative of that, and then plug in what u is, which is 1 minus 2x from the original, and then that'll be my answer. Now, letter F, as you notice, there are values, just like a definite integral here. And so sometimes you're going to have to use the same technique for definite integrals just like you did for indefinite integrals. But it's the same process. So here we'll set x squared minus 3 equal to u, and then rewrite that. Now here there is an x, but there is not a 2. So we'll move the 1/2 over, and we'll put that in. So I get square root of u to the 1/2 du. Now here, when we plug in u for a definite integral, that actually changes what our or those values are, because we're no longer talking about in terms of x, we're talking in terms of u. So we actually have to plug in 2 and square root of 7 into our equation for u to find out, or in for x to find out what our u constraints are, which will be 1 and 4 for this case. And then once I do that, now I can do my antiderivative as normal. Here I'm not going to need c because it's a definite integral, so we'll plug in 4 and we'll plug in 1. And that allows me to get 16/3 and minus 2/3. That'll give me 14/3 when I simplify, and then times it by 1/2 gets me 7/3. That's my final answer. Letter G, same idea. We'll set ln of x as u because it's inside that square. Taking the derivative of ln of x would be 1 over x. Now notice there's a denominator of x there. Now if I separated those two, it'd be 1 over x times ln of x squared. So I technically already have a 1 over x in my function. So we'll take that out with the dx and replace it with du. We're left with u squared. I'll need to plug in e and 1 into my u values to find what those values are. So that'll be 0 and 1. And then taking the antiderivative of u squared gets me u cubed divided by 3. And then using fundamental theorem of calculus to plug in 0 and 1 to find what my integral is for this definite integral. And 1/3 is my answer. Okay, have fun.